Okay, let's do a brief video on simplifying radicals. When we say simplifying radicals, we mean to keep the value of the radical expression exactly the same, but put it into a simpler form by pulling out any, in the case of a square root, perfect squares, in the case of a cube root, perfect cubes, and so on. So let's start out here with the square root of 20. So what I can do, and I can do this several different ways, but one way, particularly with larger numbers, 20 is not particularly big, but any way you can factor this will work. So whatever you think of that will factor 20, be it 2 times 10 or 4 times 5. I'm going to do 4 times 5. And then I'm going to keep factoring. So 4 is 2 times 2. 5 is a prime number, so it does not factor any other way other than 1 times 5. So that means that the square root of 20 is the square root of 2 times 2 times 5. Now, a square root means we're looking for two equal factors. Whenever we find two equal factors in a number, we can pull out one of those factors. So since there are two factors of 2 inside this radical, we can pull that out, pull one representative out. I had a colleague years ago that talked about getting that 2 out of jail. So as long as there's a pair of them, one of them can come out. Now let's do another example. Let's do the square root of something a little bigger. How about 108? 108. So again, I'm going to break that down using what's sometimes called a factor tree over here. And you can break it down different ways, but different ways of writing it. But somehow we need to break down 108 into smaller pieces, smaller factors. So 108, I know, is 4 times 27. In case you didn't know this, anytime the last 2 digits of a number is divisible by 4, the whole number is divisible by 4. So I knew that 08, which is just 8, is divisible by 4, so I knew to divide by 4, and that makes 4 times 27. And then 4 breaks down into 2 times 2. 27 breaks down into 3 times 9, and there's one more step I can do in this factor tree. 9 breaks down into 3 times 3. Again, I'm just factoring it. You don't have to go all the way down to prime numbers, but it doesn't hurt. If you're a little bit shaky on this idea, then it definitely doesn't hurt to break them down into prime numbers. So that means that the square root of 108 is 2, the square root of 2 times 2 times 3 times 3 times 3. So since we're talking about a square root here, we're looking for pairs, two equal factors. So here are 2 2's, here are 2 3's. Whenever I have a pair, I can pull one representative out of the radical. So that means 1 2 comes out, 1 3 comes out, and left over is the single 3 that was not matched up. So then I can simplify and make this 6 square roots of 3. So 6 square roots of 3, or 6 times the square root of 3, is equivalent to, exactly equal to, the square root of 108. So it's not an approximation, they are exactly equal, and 6 square root of 3 is in a simpler form. So let's move on and let's do the cube root of, let's see, let's do the cube root of 370, no, let's do 384. Trying to come up with something that is a big enough number to give us a little bit of work to do and still make it work out well. So the cube root of 384. So let's take 384. And again, I know that 84 is divisible by 4, so let's use 4 to start breaking this down. So 4 will go into 38 9 times with 2 left over, so that would give us a 24, so that's 98. Sorry, 96. Oops. Get my eraser here and fix that. 96. So 4 is 2 times 2. 96, well, 9 plus 6 is 15, so I know I can divide by 3. I also know it's even, so I can divide by 2. So let's divide by the 2 and the 3 together, which is a 6. So 6 will go in there 16 times. Okay, so now we're going to have the 2 times 2 still, and 6 breaks down into 2 times 3. 16 is 4 times 4, and then those 4s break down into 2 times 2. And again, you don't have to go all the way to prime numbers. I could stop at, oh, there's a pair of 4s. So, but just to be consistent, I'm going to break them down into primes for now. So let's see, we have 1, 2, 3, 4, 5, 6, 7 2s. So you could use an exponent instead of writing them out, but and just to be consistent, I'm going to write it out for a little bit. And 1, 3. So now, since we're doing a cube root this time, it's not pairs we need, it's triples. So we're looking for 3 of a kind. I sound like I'm playing poker. So, talking about pairs and 3 of a kind, but since we're doing a cube root, we need 3 of a kind in order to break one of them out. So that means that 1, 2 comes out for each of those sets of 3. So we got a 2 times a 2 on the outside, and then left over on the inside are the 2 and the 3. And to clean that up, I get 4 times the cube root of 6. Okay, so I hope that helps with simplifying radicals. There are quicker ways to do it, but this basically idea of using a factor tree and breaking the number down will work all the time. If you know your multiplication tables pretty well, you can probably do it faster, which is fine. but just in case you need that little bit of an extra help, a factor tree is definitely going to work. Hope that helps.